difference, which is to say our second term take away our first term. And then all we're going to do for any arithmetic, so when it's adding on, it could be taking away, just remember that's like adding on a negative number. It's going to be our first value, so a, plus 1 less than the number we're up to, times the common difference. Cool? And that's our rule. And again, a common difference, if you don't have T2 and T1, maybe you have like T6 and T5, that works as well. We're just finding the difference between two terms. Okay, so let's do some examples with this. Because it's probably seeming too easy, it genuinely is just super straightforward. So if you get the hang of it, wicked, don't overthink it. Okay, so for this example, we've got 87, 80, 73, 66, and it goes on to infinity, so it's an infinite sequence. We're going to find an explicit rule. Now that's a way of saying find the rule. Okay, don't get too weirded out by explicit. For the nth term, and then hence, so using that, we're going to find the 30th term. Okie dokes. So having a look at that question, that sequence, we know that for any arithmetic sequence, and we know it's arithmetic, by the way, because we're going to look and we're going to say, oh, okay, it's going down by 7 each time. So it must be arithmetic, okay? You also know that because it's the first example in this topic, so I'm not going to make you check that yet. We know that the explicit rule is going to be a plus n minus 1 times the common difference. So all we need to do to find this rule is to find what a, our first term, is, and then d, which is our common difference. So a, you can literally just read it off that sequence. It's just our first term. So a is just 87. And now our difference, d, again, you can grab any 2 points, any 2 terms, but it's easier to just go T2 take T1, which is going to be 80 take away 87. And again, it makes sense that we're going to get a negative number here because it's going down. That's going to get you negative 7, which is our difference. So now my rule, my Tn, my explicit rule for any term, is going to be 87 plus n minus 1. It's always still n minus 1 because I don't have an n yet. I will have an n in a second. It's going to be 30 for the 30th term. But for now, we just leave it with n times. Now, when you do this times, you could write it in multiple ways. I'm going to write it in brackets because it's a negative number. And I think that kind of like clarifies what I'm doing a little bit. You could write times minus 7, or you could put the minus 7 out front. Another thing that people tend to do is you could expand that. You could get 87. And notice if you sent this negative 7 through and expanded it with both terms, you can get, we're going to get 7 minus 7n, which ultimately is going to be 94 take away 7n. Now, both answers at this point and this point are totally correct and fine. I generally prefer to just leave it like that, but sometimes it might be a show that question. It might ask you to fully simplify. That might just mean expand those brackets and group some stuff together. Cool. So that's my rule for any number. It asked us to hence find the 30th term. So that just means pop in n as 30. Now again, we've got 2 rules that we could use. If you do it on the top row, you get 87 plus now 30, take away 1 is 29, minus 7. Or I could use the bottom rule and go 94 take away 7 times 29. Okay, I'm clearly going to get quite a negative number. Whatever you do, you can get negative 116. Done. That tells you if you continue that pattern to the 30th term, you get negative 116. Cool. Okay, so now we're going to have a look at what is called the recurrence relation. Now, that is relating a term or writing a term in terms of its previous term. It'll make more sense when we actually do it, okay? It's a little bit algebra-y. So we're going to be writing it in terms of its previous term, and then we're going to use those with a little bit of simultaneous equations to figure out stuff that we don't initially have. So that's why we're going to use the recurrence relation. If you were to do this in your exam, it will pretty much be given to you in the question and say, find the recurrence relation. Okay, so that's how you know you're going to be finding it. Now, the actual recurrence relation is just a way of expressing a term based on the one before it. So for any term, it's always going to be the term before it plus the common difference. That makes sense, doesn't it? Because you just take the term before it and then you're just adding on the difference. And if it's negative, you're just taking the difference away. Part of this rule that you will always forget is this bit at the end, where it's saying where, so comma, T1, the first term, is A. So when we write the recurrence relation, we need to know what A is, the first term, because we need to write it at the end. It might seem kind of arbitrary, but we do have to do that. Okay, so let's have a look at doing this with an actual example. So in an arithmetic sequence, it has fifth term 38. I might highlight this just so we keep track. Fifth term 38 and ninth term 66. And then we want to find the recurrence relation for this sequence. Now here's one where we don't have the first term, we don't have two sequential terms, so we can't just find the common difference. And that can be really overwhelming. You go, oh God, well, how do I even start to find the recurrence relation? Because for that, I need the difference and I need A. Well, you're going to work with what you do know. Okay, so what we do know is that for any term, okay, for Tn, it's always the first value plus n minus 1 times the common difference. Now we have 2 points that we can put in. We have the fifth term, T5, and that's going to be A plus, now I know what 5 minus 1 is, that's 4 times the common difference. And now the benefit of doing this is I know what T5 is, because T5 is just 38. And you'll notice I've set up this little equation. It would then make sense to do that with the other term, and we're going to have two equations, or as I said before, simultaneous equations. So T9, which is 66, is going to be A plus, now 9 take away 1 is 8, times the difference. If you did that with the brackets and then did your answer, because you just want to make sure you don't skip a step, that's fine. Not necessary though. Okay, now solving simultaneous equations. There are a ton of different methods you can use, and if you are getting tutored or you're working with maybe like a brother or a sister who's done maths before, they might show you one way that they think is the best. Awesome, go for it. I will show you my favorite way, and I'll show you another way that is probably a bit more common. Okay, so we're going to solve this question twice, so it's going to look like a lot, don't freak out. So method 1, we're going to do this with a little green highlighting. This is my favorite method. So what I would be doing from these two equations, and we can number them now if you like, we'll call this equation 1 and the equation 2. Okay, from equation 1, I'm going to write it in terms of A. So A equals blah, 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 blah. So to do that, all I have to do is leave A, and I need to subtract that 4D across to the other side. So I'm going to get A is 38, take away 4D. Now, could I have solved for D? Absolutely. I chose A because it was really easy to solve for, because I don't have to divide by anything at the end. Okay. So now that I have A equals, and remember that was from equation 1, okay, I can pop that A value into equation 2, and it will be all in terms of D. And then I can solve for D, come back and solve for A. So I'm going to do that. This is now, so that was equation 1. This is now equation 2, but instead of A, I'm going to write everything that I just wrote. So 38 minus 4D. Okay, so that's instead of A, I've written what A is, what it's equal to, plus 8D. Now the brackets here aren't actually doing anything, okay? They're just so that, I mean, it's just good practice when you substitute to do brackets on the first step, because there could be like a multiple, a divide, there could be negatives, stuff like that. Okay, so now what I'm going to do is solve for D. I'm going to do a couple steps in one. I'm going to subtract that 38 across from 66, and I should hopefully get 28 if my math checks out. And then I've got minus 4D plus 8D. That should just be 4D. Then I'm going to divide this 4 across on the other side, and I'm going to get D equals 7. Cool, that's the common difference for this sequence. Now, remember that for this recurrence relation, I need to also have A, okay? So if I know what D is, remember that, and I can do this anywhere, but just back here, I wrote, well, A is this. Okay, and I could have done that from either equation. I just did it from the first one. I said A is 38, take away 4D. So if I go back to that equation and go A equals 38, take away 4. Now instead of D, I now know that D is 7. And you get this little equation here. Now 4 times 7 is 28. So A is just 10. Cool. So now I know what A is, and I know what D is. I can go back and write the recurrence relation for this sequence. Okay? Because that was what it originally asked me to do, was write the recurrence